Hi, everyone. We're going to start the workshop in a minute. I'm just going to let everyone join in. In the meantime, we'll do some quick housekeeping. So, hi, I'm Udi, developer at Komodor, and with me is...
I'm Nikki.
And today, we have the pleasure of hosting our CTO, Itiel Shwartz, who will tell us all about Kubernetes Fleet Management. If you have any questions during the session, feel free to drop them in the chat below, and we'll leave time for Q&A at the end. And the deck and the recording of this session will be shared with everyone here, so don't worry about that. And I think that we are ready to get started. So, Itiel, welcome to the live workshop. So tell us what we're going to talk about today. What is fleet management and why is it even important?
Yeah, thank you, Udi. So should I start sharing, Udi?
As you wish.
You're the captain today.
Okay, so let's do it. I will say maybe some of you folks like registered and wanted to see Arthur here, which is leading our SE in Komodor, but sadly is sick. So I'm here as a replacement. So don't be alarmed if you are expecting Arthur. Just a bit about me, Komodor CTO and co-founder, a lot of background working with both Kubernetes, high, complex, low latency environment. And overall, I really like the domain and like space of the Kubernetes ecosystem. And what is a Kubernetes fleet and like why should you care or who should care? I will say that Kubernetes has started with a very cool concepts of allowing developers, right, to take their container and to deploy it in a very easy fashion. And in a way, what was created is the new mentality of cattle versus pets, and we now treat our application, our pods, our replicas as cattle. On the other side, we now created a new entity, and some will say a new problem, which is a cluster, and this entity is responsible for managing and running all of those different pods. When we're talking about a fleet of clusters, like we usually talk about a number, there's like no exact like definition, but I will say anything above like 30 or maybe like 40 clusters is starting to like being considered a fleet. And sadly, in the current ecosystem and tooling, it is becoming an increasingly big problem. How do I manage dozens, hundreds, thousands of different clusters in a simple and a reliable way? And I hope that during this, during our call today, we're going to go over like what are the challenges, possible mitigation, and also I hope to do like a very quick demo on Komodor to demonstrate how we can also help you with fleet management. But the goal here is to talk more around the problem and what you can do to resolve it, even regardless of Komodor. Yeah, anything else, Udi or Nikki?
So we see that the trajectory is going towards more and more clusters. Is that right?
Yeah, I think that the thing about Kubernetes clusters, and everyone who worked with Kubernetes know that, is clusters and nodes in general and application tends to go up, never down. And what we see is as Kubernetes is becoming more and more popular and as more enterprises are moving their stack to Kubernetes, it just means that what was once quite rare, like having something like hundreds of different clusters, is now becoming almost common for large enterprises. And we're even starting to see how like 500 and 600 clusters is like, okay, like that's not too huge. So we are in a trajectory of only going up, and a lot of different like tools and the CNCF and Kubernetes itself are trying to tackle this problem, this like fleet management problem. But why? Maybe let's talk about like why is it a problem? Sorry.
Oh, I just wanted to ask if it's also to say that like the trajectory is going like up the stack, or if most of the focus in the early Kubernetes releases was around pods, and maybe then about nodes. And now, like in the last year or two, we're seeing clusters become like first-class citizens in the IT infrastructure space.
Yeah, I think, Kubernetes in general wasn't that popular, right? Like 5-6 years ago, it wasn't really like production ready for a lot of the people. And a lot of people, again, like treated it as like a new unreliable technology. As big companies like move into any domain, you start seeing supporting infrastructure and different scaling problems that emerges. I think Kubernetes, in terms of how do I manage my application on a single cluster, has reached some certain of maturity. And that in turn means that new problem, like more people are adopting it, and then more new problems are created by the move of those like very large enterprises and companies to Kubernetes. So I think it's around, like maybe like you said, it is a kind of evolution of going from like a small amount to a bigger and bigger and bigger environment.
All right.
Okay. I won't go too much into like the definition of like what is a fleet management. I think we did cover it. But I will say when we're talking about fleet management and who should care about a specific like managing the fleet, we usually talk about platform engineers, platform team. I will say the term itself is inaccurate, right? Like some people will call it like infrastructure group, some will call it like cloud ops, whatever. But those are the people who are responsible to giving this supporting layer, this supporting infrastructure to the rest of the organization. And we know that most of the time organization technology looks like the organization HR like a map basically. And if we have different business units with different people, usually what we're going to end up is something maybe similar to that we have different business units, and each business unit has its own requirements and regulation and developers, and some of them maybe have their own like mini platform team also managing it. And the centralized platform team is usually the one responsible for managing this fleet. They are the people who are responsible for managing dozens to hundreds to even thousands of different clusters. And this poses like two main challenges. One of them is more technical. Simply, how do I do it? If I have 100 clusters, how do I operate and keeping myself sane as like a platform person? And on the other side, we have the human factor. How do I make sure that the rest of the team, the rest of the people are still empowered, even that I'm this like platform team that supports them? How do I give them the relevant tools so they will be self-sufficient and they won't require me? And the golden, like what everyone are trying to achieve is to a state where everything is super reliable, very easy, but in reality, the world is a bit more difficult. So when we're talking about managing a fleet from like a technical aspect, I wrote here like 6 main areas, which are like the cluster lifecycle, access management, cost, resource, and utilization, governance and standardization, reliability and resiliency, and cross-cluster visibility. I'd say most of the problems that you see here are not really unique to a single, like to a fleet of clusters. You might say, yeah, but yeah, like in the end of the day, all of those problems also exist for a single cluster, right? But the problem when you have a lot of different clusters, then things that were easily solved by manual action maybe, or by doing some hacks or tricks or scripts or whatever, they don't really scale. The RBAC doesn't scale, the cluster lifecycle doesn't really scale. And once you go into a certain stage of number of clusters, the complexity of managing those clusters, of making sure that all of them are like cost efficient, and the governments and the relevant core application are installed, and access management, like all of those small things for like a single clusters are becoming huge. And you find yourself like in the old days, we worked really hard on managing like a single application. We're working really hard in a lot of like manual tip tricks and like hacks in order to manage these clusters. And a lot of what we see from even our customers is they go back to like the old fashioned tools of like Ansible or Chef or Puppet in order to manage a fleet of Kubernetes clusters, which is like, a bit counterintuitive when you think about the promise of Kubernetes and the promise around eliminating the need of those kind of tools. Again, like I did work with, Chef and Ansible quite a lot, but in the end of the day, I think Kubernetes had the promise of like, you don't need all of this anymore, but it turns out we do. The second very important aspect of like fleet management is, okay, I have this fleet. The problem with this fleet is it's not like a car fleet that all of the different cars are the same. Not all of the cluster are the same. Some of them are like Jeeps, and some of them are SUVs, and some of them are motorcycles, and some of them are, I don't know, like even bicycles. And each different cluster has its own different flavor, and the personas that are using it are different, and they want to achieve different things. And that in turn, the fact that you have different clusters that different people are using with different expertise level, with different expectation, this leads to something that is like a lot of the time chaos or like chaotic. And we see that like platform team are trying to figure out what is the right abstraction, what power should I bring those developers, those end users, and what power should I not give them, and I should like keep for myself. And finding this balance is very, very challenging, not only from like a technical aspect, but also how do I take this and trickling it down the organization, like command center basically, and making sure that everyone is happy or at least not sad. And we see a lot of the platform team, by the way, that allow their in the organization, they do allow the developers to use like bare metal or like EKS. But the platform team goal is ultimately to own this part and to simplify the process. Okay, so we talked quite a lot about the problems maybe of how do I manage a fleet of clusters. Let's talk a bit about how we can do it at scale without going crazy. So one thing is to start thinking again, like, and it is a very common pattern in security, in RBAC, the ability, or like in any kind of like monitoring and observability tool, the ability to have attributes on top of your cluster. An attribute might be something like a region, environment, cloud provider, namespace, a business unit. What we're trying to do is to make sure that we have some kind of segregation and visibility, and we take this like very large fleet and we try and have different standardization towards different families. Maybe in production, I have different requirements, and in dev, different other requirements. Maybe for some BU, because it is in Europe, it acts differently than all of the clusters in Asia or in the US. So we need these kind of things, but it's not like different families. Like a cluster can be both prod, certain BU, and certain kind of regulation. So it is important to have the relevant attributes on top of each one of your clusters. I will also say that one of the cool things, which is like a subset of fleet management, is basically Kubernetes on Edge. There was a very popular blog post like 5 years ago, I think, by Chick-fil-A, that wrote about how they're using like a Kubernetes cluster on each one of their branches. I will say this use case of Kubernetes on Edge, Kubernetes IoT basically, became more and more popular, and we see it from fast food companies to like stores and e-commerce and like physical brick and mortar shops. And we see across the globe that managing a fleet of Kubernetes cluster is becoming more and more popular. And a lot of the times it's even like fleet on fleet, like fleet of ships that are running their own Kubernetes cluster. So we see quite a lot of like interesting use cases around Kubernetes. And again, with each new technology, it comes with its own price or its price tag. So what can we do? How can we, as platform engineers or DevOps or production engineers, manage this fleet? And I wrote here like the main like 5 points that I think are most important. I think the number one is like a must. Like you must use some sort of IAC, infrastructure as code. We see a lot of people starting to use Crossplane. Terraform is obviously like the king, and a lot of usage around cluster API as well, meaning like one cluster that helps you to manage a different kind of clusters. So we see it as something that is a must when you manage, again, like hundreds of different clusters. A second thing is like GitOps. It goes almost hand in hand around IAC. But when you have a fleet, what we are trying to do is to write as less boilerplate as possible and achieve a certain of standardization across the fleet. And like those two are super important. The third and fourth are more like a day two. Okay, like now I have all of those clusters, I have this fleet. What can I do? How can I manage it? What am I going to do with all of these like different cross-cluster, cross-region, cross-cloud provider hybrid mode? And for that, we need some sort of both monitoring, traditional monitoring, and also probably some sort of Kubernetes specific monitors that allows me to see different clusters in a single pane of glass. And the last thing is some sort of internal tool around fleet management. Some people go to like the legacy player, I will say, like the OpenShift or Rancher or Tanzu. There are modern like players, and like Komodor is one of them. And some even write their own like system using Retool or any other mechanism, Upsmith, in order to manage that. It doesn't really matter. But if you reach like 100 different clusters, you should have some control plane to manage this fleet. I will say when it comes to managing hundreds of different clusters, thousands of different users, what we're trying to achieve, I think what every platform engineer wants is to be like a kind of like an Amazon AWS, where the developer are self-sufficient, they are empowered. When I spin up a new AKS cluster, I never talk with the AWS support. When things go wrong, I also don't talk with their support. I try to figure it out myself. I'm like self-empowered to use AWS. What platform teams are trying to do is do this shift left, the ability to empower developer into a state that they are self-sufficient, that they are able to solve issues by themselves without needing to escalate it, without talking with the DevOps team, without talking to the platform team. And it is important to remember hiring good people in a platform team in a fleet management situation is hard and very costly. And you can't scale your team the same way that you scale your cluster numbers. So you must empower your developers in order to achieve a real efficient and healthy state of Kubernetes fleet management. I will say in Komodor, we also have quite a lot of fleet management capabilities. What you see here are like different clusters running on different areas in the world, basically. And I'm going to do a demo very soon. And I think now it's time for demo. But before I will demo, I do want to open it up for question. If someone have any kind of questions, please do it now. Odi, I'm not sure if they can ask questions.
Yeah, they can in the chat.
Mm-hmm.
Anyone can write a question directly in the chat below.
So I'll give like a minute or two if someone wants.
People are shy, so I actually have a question while people are scratching their heads.
They're thinking.
You've mentioned the human factor. We talked about it a lot, and you're also the host of the Kubernetes for Humans podcast. So I already know the answer, but how important do you think is the dev empowerment? Because one solution is to automate everything or just have a huge platform team or a SRE team that consolidates everything and the developers don't need to do anything other than write code. So like there are other ways to do it. So do you think that none of it is complete without also onboarding more engineers into the Kubernetes world and being able to offload tasks to them?
I think you can't reach like a really scalable like solution without maybe like spend shit ton on money on like, you know, like having a lot of DevOps, but it's almost impossible. Or to do this shift left, like it's one of the two and you can't really achieve them. Like you can't live up without those. And what we see is a lot of the time customers that did reach a certain point of scale that they are going backwards. They are not moving as fast as they want. And this is usually because their developers are blocked and they are unable to act alone without basically some sort of help from the platform team. And again, you see teams that moved in a certain velocity, and then it went down because your developers were simply not empowered.
So basically, the Kubernetes adoption turned out to be the opposite of the expectation.
Yeah, sadly, that's what we see. It's a question of time. Like over time, companies do find that they are able to do it by themselves, and they build relevant tools and processes, but usually it's a lot of time and quite costly. Okay.
And do you see like common patterns from some of Commodor's larger customers of how to solve those things, or like different ways of approaching the issue?
Yeah, I think that the main thing is like have a good set of expectation regarding what should a developer know, what can he do, making sure that he has the right infrastructure and the right tools in place, and then to spend time on that, like telling the developers, doing the workshop, doing the training, giving them the tools, and then you are starting to reap like what you saw. But usually it does take time, it does require tooling, and it does require some cultural changes in order to make it happen.
Okay, one final question before we move on to the demo is, how do I know if I'm the owner of the platform, if I'm the head of SRE or whatever? How do I know that I've reached the point where, like, what's the tipping point?
When you become a fleet.
Yeah, when
When are you a fleet?
when are you a
Yeah.
fleet?
I think
Number of clusters that you reach, or is there a certain metric that once you notice it's
I think it's
down like
the question of
something else?
I think it's a question of toil and maybe like escalations as well. How much time are you spending on like doing grunt work of like patting or herding your clusters basically, compared to how much time you used to? And if you see this like going up linearly or even exponentially sometimes, then you are in a wrong place, and you should probably search for some tools to help you or to change something in the way that you're operating. So I think it's a question of toil on one hand, like how much time are you spending, and also how much time are you spending supporting different teams in your company, basically.
Okay, one last question, final is, can you automate everything? And we actually have another question from the audience, so I'm gonna let Bruno priority over myself because I've already asked enough questions, but I do want to get back to the question of automation. So Bruno's question is, Nick, you want to read it?
Sure. So Bruno asks, how would you say is the best way to release new versions of the clusters? How can you ensure that everything will work if the different teams that run applications on these clusters have many different tech stacks and frameworks? I don't mean Kubernetes versions only, but all the changes on the tooling that runs on the cluster.
Yeah, I think it's a great question, and I will separate it into like two main things. There is making sure that the cluster itself can be released, and you have some sort of cadence around cluster releases, and making sure that you are in like the GA or like close into the GA. And this is something that you need to do internally. There's the second layer, which is the core application and add-ons or plugins that you have on top of your cluster. What I would recommend is for the platform team to manage all of it. And once you do have everything managed, then again, it's up to you to create this cadence of upgrading those tools. The third level, then that sometimes is more tricky, is when your developers are doing some sort of upgrades that you are unaware of, or that can break your system. And in those cases, sometimes it is unavoidable. Sometimes it's a question of communication, letting them know that certain features that they own reach an end of life, and it's up to them to upgrade it, and making sure again that you have the right tooling to support you around that. After you have all of this, if we're talking about the technical aspect, we do see that for some clusters, they are trying to do like blue-green clusters. If you can reach to that stage, it's great. Usually it's quite hard. And if not, it's doing it in a gradual way on one hand, but do have some sort of families that you upgrade if possible, like in a like a streamlined fashion, like after 1 or 2 canary, you upgrade the entire group. So this is how I recommend. I hope it answered the question.
Yeah, and I think the demo will give some more ideas and insight. Bruno says thanks. Thank you for the question, Bruno. And maybe you should also look into IDPs while you're at it, because there is like a broader area of problems and complexities that needs to be consolidated, and that's one of the solutions. And so before we move on, automation. Why can't I just automate everything? I don't need to empower developers. I can just let them go and empower an AI agent.
Yeah, I think it's first of all, I think AI does play and going to play a major role in helping the developers to improve their work and self-empowerment. And in Komodor internally, you are spending a lot of efforts around like using Gen AI and AI in general in order to improve and to help developers to streamline their processes. That being said, I will say it's a bit like autonomous cars. Like everyone don't want to ride, right? Like I don't want, but on the other hand, no one trusts the robot well enough so far. So I think when it comes to like taking the developer out of the loop, we are not there yet when it comes to AI. And I think for the upcoming decade or so, we're not going to be there. We should use AI in order to empower them, more like an iron suit than anything else.
Cool.
No one else has any more questions. I think we can move on to the demo.
Okay, so let's do that demo. So what you're going to see here is Komodor cluster capabilities. It is a feature that is already being released, I think, in a beta for Komodor customers, and is going to go GA next week, right, Udi? Yeah.
It
Yes.
actually is already GA.
Oh, we did we're going to do like a big announcement, right, and like sharing everything to existing customers and also like beta use with like free self-serve users as well.
It's exclusive for the workshop. They get to hear it first.
Yeah. And what you're seeing here is Komodor way of showcasing you all of the different clusters in one single pane of glass. And you see here a cluster both from Azure, AWS, Google, it can be on-prem, everything that you are managing in one single place. For each cluster, Komodor focuses on 2 main aspects. The first one is to tell you about critical issues, critical problems, things that you should fix right now across your system. So this is like the critical issues part. The second thing that we give you is scores over time. And our goal in life is to make your life easier. And we do that by making sure that over time, your clusters are more reliable, more cost optimized, and that they work better. And to do that, what we offer our users is the ability to understand what is currently not working in my system. That doesn't necessarily mean that the system is down, but if I'm not going to attend it, things are only going to get worse and worse over time. So Komodor reliability is our unique approach of, on one hand, taking like static YAML analysis and helping you find issues and problems, and to combine it with the real world, what is happening, what do we see, and helping you to close the loop between the static, the actual results of this like static configuration on the real world, and then to help you close the loop and change the relevant YAMLs using infrastructure as code and solve the issues before they escalate and before you're going to reach like to a really bad state. And I'm going to share like a couple of examples because I don't think we have a lot of time for the webinar, right? So I'll try to keep it brief. We have here a couple of violations. Like I said, violations is Komodor approach of telling you, hey, you have a problem. You should do something around it. And if you're not going to do something, then things are going to fail and be less reliable, and it's going to affect your MTTR, MTTD, uptime, and so on. And we have here like a couple of examples. We have like one example that this cluster is reached in end-of-life state. End of life means in AWS that you're going to pay like 20K a year or 30K a year on managing this cluster if you are not going to do the upgrade and when they tell you to do the upgrade. More than that, we see that sadly in this situation, we can't do the upgrade. We are forced to do some APIs changes before that. And this is like tied to Bruno's question. We see that some developers are using applications that need to be edited or changed prior to doing the upgrade because their APIs are being deprecated. And in Komodor, what we do is to tell you like what you should fix, what's the impact, and what happened, what you should fix, what's the impact, and also to guide you around solving it. So here we're walking you through the upgrading process so you won't work that hard on upgrading your system. A second example might be a node pressure and a noisy neighbor. A noisy neighbor is basically one service that is hurting the node, which is in turn killing other applications running on the same node. So in Kubernetes, when we're talking about reliability, it might be around the cluster itself. It might be around the underlying infrastructure, nodes, PVC load balancer. It might be around the application. And sometimes it is in the weird synergy between those three, like the application is impacting the cluster, impacting the node, impacting other applications. And in this scenario, we see that we have one application that is killing other application because it is not configured correctly. We can see it killed 26 different applications. And in Komodor, again, we give you the relevant recommendation, the relevant remediation around solving that particular issue and that particular problem. We have, like in Komodor, dozens of different reliability checks, which their sole purpose in life is to make you as the one managing the cluster life easier. And we can give you that in a way that makes managing Kubernetes clusters at scale from something manual and tedious into something that is, okay, like I have a supporting tool, so it's not going to take me a week, it's going to take me, I don't know, like a day. Policies is something that I don't think I need to explain too much, but I think having the right standards in place is critical when we're talking about fleet management. And in Komodor, we can integrate with Kyverno, we can integrate with Oppa, and we can also use our own recommendation. And in this example, we have a really good recommendation around making sure that your pods are spread across the topology in a way that if you have a problem with the node, you won't experience availability issue, you won't experience downtime. Cost is, I think, one of the more popular things in the last year or so. As you scale your cluster, you usually scale your cost. And in Komodor, we help you to find the right balance between cost and performance. And in this way, you can know how much each cluster costs you, how much each application and namespace costs you, but also what applications are under optimized. And again, as we know that Kubernetes can and will grow, the cost will grow. With Komodor, it's a bit like mowing your lawn, making sure that every time you have the right checks and balances in place, so you are not going to go splurging and spend too much money on your clusters. The last thing that I want to showcase in the cluster fleet management is our very unique ability to set in one single place the RBAC for all of your different clusters. So in Komodor, you are able to configure the actions, policies, roles, and users in a way that we are becoming the single source of truth for managing those clusters and their RBAC and access management. I think when you have hundreds of different clusters that are hybrid and cross-cloud, this is almost impossible to do manually. And you are probably invented your own scripting methodology in order to make it work. In Komodor, you can get it in a couple of minutes. And you are getting things like just-in-time access, temporary roles, and the ability to download the relevant kube config if needed, and also to view the relevant audit logs of who done what, in which clusters, in which regions. I think I concluded the main areas around cluster and fleet management and cluster management in Komodor. I will say that customers that onboarded Komodor usually see a reduction of between 60 to 80% in their toil and their escalation. And that means that their dev team move faster. The platform team don't spend a lot of time on manual toil, and the organization is gaining much higher velocity. Any questions here?
We have a question from Bruno. Do you also take add-ons versions into account for Kubernetes minor upgrades like kubeproxy, VPC CNI, accordance, etc.?
Yeah, it's a great question. It's very relevant for AWS that tends to have like breaking changes for their add-ons. It is something that we're now adding, the ability to understand the compatibility between those kind of add-ons. But great question, Bruno, and we know how hard it is to upgrade those add-ons.
Yeah, and I remember a specific case with one of our customers. It was acquired recently. And I don't know if you remember this, but they also had a breaking change with their CNI, and that Datadog couldn't pick it up because there was no traffic coming in, and the end users were the one complaining that that there's something broken with the application. The engineers on call looked at Datadog, saw that everything was fine, and couldn't reconcile the situation. And only with Komodor, they figured out the error message, understood that it was an issue with the CNI, brief glance at the AWS documentation, and they understood what they need to do to resolve it. And that was a long time ago, before like the new stuff that you are referring to will be rolled out, which will encompass more of the entire ecosystem around Kubernetes, right? Not just the.
Yeah, no, completely. I will say we see like fleet management and supporting those platform engineers and their core application as something crucial for Komodor for like the next of like, you know, the upcoming year. So if you are running a fleet of clusters and you are having issues, feel free to reach out, do free trial, or even ping me directly over LinkedIn or over email. Yeah.
All right. Okay, fine.
Yeah, Bruno has another question.
Yeah, you need to cover every use case and every.
No, I
I
think it's great questions, and we're spending a lot of less fun.
Bruno, keep them coming. That's why we're here. You're making us happy.
Yeah, so you want to take that question, Itiel?
No, I will say that like this is one of another thing that we're tackling now around cluster upgrades. Like if you onboard to Komodor today, we won't see it. If you'll join and like talk to us, it is something that will allow you to be in like the beta testing. And if you're Bruno, I'm not sure if you are like an already existing customer, and if so, you know, let's talk afterwards. But we are going to add more and more capabilities into that node operation system and Kubernetes. There are like Kubernetes breaks, AWS for cloud specific breaks, and add-ons breaks. And our goal is to alert you prior to each one of those. And we're also going to do like analysis of the Helm charts that you are using, and also to alert you on upgrading those kind of like things in the future. So let's talk, Bruno.
All right. So thanks, Itiel, for this insightful workshop. Thank you, Nikki.
Thank you, Udi.
Thanks everyone who joined, and Bruno, thank you. Itiel is not a customer. I know all of our customer names by heart, and he's not one of them yet. But thank you for joining, Bruno. I hope it was insightful and helpful for you too. And like I said, we will share the recording and the deck with everyone who registered. So you'll have a chance to review it. And feel free to reach out to Team Komodor or directly to Itiel and ask questions and engage with our next events. When is our next event, Nikki?
At the end of July, we've got another workshop coming up. So stay tuned for that.
Yeah. And finally, let's all wish speedy recovery to our dear Arthur, who's at home sick. And thanks, Itiel, for filling in on such a short notice.
Sure.
And we'll see everyone again next time.
Pleasure.
Thank you, everyone. Have a good day.